class for the exam you are facing. You will be writing tomorrow probably. We are here for the final revision. We are a bit late, but I assure you the classes are very valuable for you. We are on to the best channel that will teach you and guide you for your exams. Okay, so you're welcome. You're welcome once again. Let's do this as usual. The last ones we did has been very useful and helpful for most of you guys. So this time around we are here again to do it. Remember that the questions are here, but it will be better if you bring your own questions too. It will go a long way helping me to provide the useful answers and then solve your own personal problem. Maybe you are reading and you are unable to get some messages. So these are the questions, the practice questions we are going to be using for this live stream, right? So the previous ones we did, like I said earlier, most of you confirmed, even though it's not my practice related, but it was very much useful. So some of you online, I say you're welcome. Please endeavor to share this video. If you are on to enjoy this live stream, make sure you contribute by asking your own questions using that live chat. It will go a long way. Okay, it will go a long way. Thank you for the like. We have come again. It might be your own questions that will help others. Okay, so definitely I will do small parts, maybe the first 4 objective, then the last 4 I go to some theory. I'll be switching them. Then eventually, look up here. This one says you don't mind the markings. If you check, it might not rhyme, or maybe okay. The 50 says an element that can exist in 2 or more forms in the same physical state is said to exhibit in the same physical state. That is exhibiting allotropy. So 50 is D. Okay, although we know that I think we go to other one. 50 here is D. Ask your question, so I repeat. Okay, we don't know how this might work out. And a mixture, they say a mixture of potassium chloride and ammonium chloride can be separated by potassium chloride do not sublime. Ammonium chloride sublimes on heating, so you use sublimation. When you heat it, ammonium chloride, you collect it as the sublimate, and then leaving behind your potassium chloride. Okay, now the question 48 here says how many bond pairs of electrons are present in the following molecules? How many bond pairs? Let me pick the pen and write on it direct. Here we have to be careful. Bond pairs. Thank you guys for liking. If you are on, you hail us. Okay, so let's check bond pairs. They say how many bond pairs of electrons are present in the following molecule. Remember that a covalent bond means a shared pair. So when we say shared pair of electron, it is nothing but what? A covalent bond. Shared pair of electron means covalent what? Bond. So bond pairs, let's be okay. Victor Bassi. Oh, thank you for the compliments. I got you. God bless you so much for your followership. I cannot do without you guys. So make sure you spread the light. If you are not the candle producing the light, can you be the mirror that reflects it? So how many bond pairs of electrons are present in the following molecules? Bond pairs, like I said, Lindia, we said that these questions are for revision. We called it revision. I repeat, this is Majestic Tutorials. We don't engage in malpractice. But those that have participated on our last revisions came out with smiles all over their face. So if you listen well, you learn. If you are looking for malpractice, check elsewhere. I'm sure many people have leaked the real paper, so you can search for those people. But it will be more honorable if you learn and write the exams by yourself. Just listen to me, it will give you not less than 50% help or even 70% tomorrow. Just get the explanation, okay? Bring your questions instead of asking whether it's a real question or not. Are they fake questions? Are these not chemistry questions? So what will you see tomorrow? Chemistry questions, okay? But I want to make it clear, even if I have access to the real questions, I'm not going to display it because I'm Majestic. For now, I might not be the best, but I'm trying my best to restore the dignity of science and learning to make education valuable, okay? I hope I've answered your question, the person that asked that question. So bond pairs, let's count. Each line here is a bond. This is 1, 2, 3, and then 4. But don't answer 4. Do you know why? This is 1, 2, 3, and 4. This dash dash. But don't answer 4. Why won't you answer 4? It's because there is still another bond pair here. I will expand it. This is 1, 2, and 3. So we have 1, 2, 3, 4 plus 5, 6, 7. So the correct answer is A. There are 7 bond pairs and not 4. Okay? So that's it. Then the next question is, it says, which of the following compounds can be identified using ammoniacal silver triazonitrate 5 solution? Ammoniacal silver triazonitrate 5 solution is used to distinguish between alkenes and alkynes, okay? Between double bond and triple bond. And if you look at the options, we have B and D. Option B and option D both have this triple bond. So which one should be the correct answer? Automatically, the correct answer is nothing but the terminal one, the one that is at the end of the chain. So B is a terminal alkyne, meaning this is 1, 2, 3. Okay, preferential discharge of ions in an electrolyte. I will do that. Thank you. So 1, 2, 3, 4. So this is boot 1 in. Why this is 1, 2, 3, 4. This is boot 2 in. So boot 1 in is a terminal. The triple bond is at the end of the chain. The correct answer is B. So looking at preferential discharge of ion, for one of you that are online, your question is okay. Remember, we still have this oh, thank you, Lindia. God will help us. Definitely, I pray this class will help you, okay? It's going to be very much helpful. Spread the light for some people to join Majestic Tutorials. I think these questions here are not clear, but I'll still come back to your question. I feel like answering this. They say state the law of constant composition, state 2 uses of standard electric potential, state the law of constant composition. This is what we know already. Law of constant composition is also called what the state uses of 2 standard electrode potential. You know that, so you study having seen it, you do revision on that. Is the potential difference setup. Is the potential difference setup when a metal half cell is connected to hydrogen half cell. That's hydrogen, we call it standard hydrogen electrode. That's the determinant. When you connect metal to standard hydrogen half cell at 25 degrees and the solution is 1 molar. So we must be careful about the situation here. Standard electrode potential, you must mention the temperature 25 degrees. It must be 1.0 mole per dm cube. That's a molar solution. A molar solution, 1 mole per dm cube. So these are the standard conditions. Then you have to compare it with metal, let's say copper solid, that's copper electrode inside copper 2 ion half cell versus this double slash means salt bridge versus copper, not copper, versus hydrogen now, please. Versus now hydrogen ion, which is aqueous. This one is aqueous, and hydrogen gas system. And the temperature is 25 degrees, and the solution of this is 1 mole per dm cube. Whatever it reads, the EMF, the standard, the electrode potential it reads is called standard electrode potential. So by definition, standard electrode potential is just the potential difference when metal ion half cell is connected to hydrogen ion hydrogen half cell, or we call it standard hydrogen what? Electrode. That is the She. You can approximate it as She, okay? So that's just by the way we go. It must be at 25 degrees. The uses is that it helps us to predict reduction potential. You know that metals are reducing agents because they donate electron, the ability to donate, the one that donates faster. So the donation potential or the reduction potential. Then it also predicts the reactivity of metal. Standard electrode potential is also used to determine the EMF of, I'm answering this question. They say state 2 uses of a standard electrode potential. It is applied in determining the EMF of a cell, a dry cell. And I said it is used to know, also determine the reactivity of metal and also the reduction potential of metal, which one have more reducing ability than the other, okay? They say states the law of constant composition. This law is also called law of definite proportion. So we call this one law of definite proportion. That's another name for it. It states that all pure samples of a given compound contain the same elements in fixed ratio by mass, irrespective of the method of preparation or the source of the compound, See what we say here. We are saying that if you get pure water, all pure samples, if you get pure water, whether you get it from borehole, from spring, or from sea, as far as we have purified it, it must contain hydrogen and oxygen in the ratio of 2:1. Then if you have sodium chloride, or whether you go to the lab now, spark and burn hydrogen in the presence of oxygen, it will still give you water, which should be in the ratio of 2:1. So whether you make the water in the lab or you get it somewhere, since this pure water, it must have the same element and in fixed ratio by mass. Remember, whenever it is now H2O2, this is no more water. This is now hydrogen peroxide. It's no more the same thing. So this is trying to tell us that no matter the source of a compound, as far as it's pure, they contain the same element. Students often say, can you use sodium chloride you produce in the lab for cooking? Yes, but it is wasteful. It will waste time and money producing sodium chloride, since it occurs in nature as sea salt. Most states, like Ebonyi State in Nigeria, mine this salt. But if you make this thing in the lab, through neutralization, and you are sure you have purified it, you test it. It is the same thing as sodium chloride. Where this is applied is that in the world today, this thing is what people consume, C2H5OH. This is ethanol. Different tribe have different name for it. Some might call it kai kai. You can get this thing from palm wine. You can also get this from hydration of ethene in the lab. So but you see, the village people, they will be telling you that the one gotten from palm wine, because palm wine contains the ethanol already. Your job is just to distill off the ethanol in it, concentrate it more. But this one from ethene, you just hydrate it in the presence of acid, add water to it, it becomes ethanol, but not just simply adding water. Some people will tell you the one gotten from palm wine is the best. It's funny. Hydration of ethene, as far as it's pure, it is the same ethanol and they will give the same effect, okay? So all pure samples of a given compound, irrespective of the method of preparation, as far as, remember, what matters is that it's pure. They say pure sample. So not when you don't maintain that term pure. All pure samples, that's when it works. Now, let's forge ahead. They made a table. They say two different samples, X and Y, of zinc oxide were heated in a stream of hydrogen to yield the following results. Okay, two sample X and Y of zinc oxide. So we are talking about zinc oxide here. Were heated. So the mass of sample 12.5, then 10.00 for Y. They say use the above data to illustrate the law of constant composition. What are you going to prove? In sample Y is zinc oxide. Sample X is still the same zinc oxide. So how will you prove constant composition? The ratio of mass of zinc to oxygen should also be the same thing in both cases. So if they are the same, it means law of constant composition. So what are we going to do here? We will find out the mass of zinc and the mass of the oxide. Look at the mass of sample. Mass of sample is 12.5, meaning the mass, both the zinc and the oxygen, is 12.5. This is the mass, both the zinc and the oxygen. But after heating it, the oxygen is derived away, collected by hydrogen to form water. The zinc remaining is 10. So in sample what? Permit me to clean off. So you just do your calculation. You say in sample what? Sample Y, mass of you say 12 point what? 12.5 minus 10.0 is what? 2.5 grams, which implies that 10 grams of zinc combined with what? 12.5 grams of oxygen. Okay, and then in sample X, you still do the same thing. You do your mathematics. 10 minus 8 is equal to 2 grams. This means that in sample X, that 8 grams, remember this is the mass of zinc, 8 grams of zinc combined with what? With 2 grams of, because we got to here, 2 grams of oxygen. This is oxygen, so that you don't see it as zero. Now check the ratio. The first one in Y, what's the ratio of zinc to oxygen? 10 is to 2.5. Is it equal to 8 over 2? Yes, of course. 10 over 2.5 is 4, and 8 over 2 is 4. So that is constant composition, right? So they said, I hope we understood this. I think I'll now go and solve the problem on, somebody asked question on, I think, preferential discharge, okay? Preferential discharge. So let's allow this to. So the factors, it is better you send in a question for that preferential discharge. There are factors, the three factors that affects the discharge. Factors during electrolysis. J. Kings, you're welcome. It said factors that affects the preferential discharge of ions during electrolysis. There are three of them. Number one is position in the electrochemical series. Songo Israel, you're welcome. You're welcome. Then number two is concentration of the ions. Then the last one is nature of electrodes. Oh, Gentle, how are you? You are the J Kings. Yeah. Nature of electrodes. These are the three factors that affects the preferential discharge of ions during electrolysis. I hope the guy that asked this or the person that asked the question is still online. Normal for the first one, you just have to write the electrochemical series, which has potassium, though in your book they skipped calcium, sodium. Don't correct me, don't tell me it is potassium, sodium. No, that one is reactivity series of metal. But in electrochemical series, the correct thing is potassium, calcium, sodium. That's the difference. So even though reactivity series and the electrochemical series looks as if they are the same thing, but they are not exactly the same. Potassium, calcium, sodium for electrochemical series. But in reactivity series, it should be potassium, sodium, calcium. Sodium is more reactive than calcium. But unfortunately, the standard electropotential difference of calcium is more than that of sodium. I've explained how to get standard electropotential by setting the half cell of a metal with standard hydrogen electrode. Okay, so we have potassium, calcium, sodium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper. Basi, you're welcome. Copper, mercury, silver, and gold. Okay, that is it for the cations. Then for the anions, we have it this way. We have fluoride ion, tetraoxosulfate 6 ion, trioxonitrate 5 ion, chloride ion, bromide ion, iodide ion, and hydroxy ion. And the arrow, this is for the anions. This is the electrochemical series. Remember, this arrow means increase in preferential discharge. Increase in preferential discharge. Meaning that if we have bromide ion and hydroxyl ion, that hydroxyl ion will be discharged. The same thing is applicable for this cation side. It will have, this is increase in preferential discharge. This implies that as you move down, gold is the last bond that will go out first. So gold will be discharged. If you have mixture of hydrogen and gold, gold will be discharged. Hydrogen and copper, copper will be discharged. Okay. So let us apply this with few examples. Okay. Thank you for liking. Let's assume they tell you that this compound is electrolyzed, copper 2 tetraoxosulfate 6 aqueous. If you see aqueous, it means that water is added. So when we say aqueous, we have two compounds. Immediately you see aqueous, two compounds are involved. What are the two compounds? The salt itself mentioned, you dissociate it. It will give you copper 2 ion and tetraoxosulfate 6 ion. You see it now. And then the second compound is water. Are you with me? It is water because aqueous was mentioned. If aqueous wasn't mentioned, you don't need to put water. If they say molten sulfate, molten salt, the water is not there. So the water will also dissociate to give H plus and hydroxy ion. Now, if you see plus plus during electrolysis, these ones are called cations, while these ones are called anions. So in this case, cations will go to the cathode, and hence their name cations. That name cations means cathode ions. So these ones will go to the cathode, and there will be competition, Cu2 plus and hydrogen plus. You now refer to your series. Are you seeing them? H plus and Cu plus. So copper 2 ion is lower. So what will be discharged at the cathode during the electrolysis of this compound is what? Copper at the cathode. What will be discharged is copper, because copper is lower than hydrogen. Okay, so your copper, you now write copper 2 ion. To complete the half cell, if you see plus 2, just add plus 2e. Let's assume we have Al3 plus. I'll just say plus 3e plus the same number I'm seeing. You get that now? If I say O2 minus, I'll still say minus 2e, the charge. This E is electron, all right? That's how to write the half cell equation. So you need to know the charges on each ion. So Cu2 plus 2e to give you what? Cu. This is S. This is aqueous. This means that copper is discharged at the cathode. Now, let us change the scenario. Let's assume we are now electrolyzing magnesium or zinc sulfate. Let's use common compound. During the electrolysis of zinc tetraoxosulfate 6 aqueous. Lest I forget, when you come to the anode now, you see tetraoxosulfate 6 ion and OH. OH will go because OH is higher. See the position. This SO4 is even 4. Is it further away below the series? So this one will go first. So what will be discharged at the anode? Let me finish it up. At the anode, OH, and OH is discharged in form of oxygen gas. So hydroxyl ion will be discharged, but in the form of what? Oxygen gas. So the half cell equation is simple. 4OH minus to give 2H2O plus oxygen gas plus 4 moles of electron. So what you should also learn here is that we need 4 moles of Faradays to discharge 1 mole of oxygen gas. Remember, oxygen gas is diatomic, all right? So oxygen will be discharged because it's lower in the series, while copper will be discharged at the cathode because it's lower in the series. Another scenario is, let me repeat the same using zinc sulfate this time around and no more copper sulfate. Remember, you are on the Majestic tutorials, okay? We'll give you the best. Let's assume we have zinc tetraoxosulfate 6 aqueous. From what I told you, immediately you see aqueous, there are two what? Compounds. Zinc sulfate will dissociate to give zinc 2 ion and tetraoxosulfate 6 ion. Then another one is water, because aqueous solutions are solutions in which water is the solvent. Aqueous solutions are solutions in which water is the solvent. So H2O will now dissociate to give H plus and OH minus. So what will be positively charged? Zinc and hydrogen will go to the cathode. Which one will be discharged? You look at our electrochemical series, ECS. We are looking at zinc and hydrogen. You see, zinc and hydrogen. Hydrogen is lower. Therefore, hydrogen will be discharged in this case. So if you electrolyze copper 2 sulfate, copper will be discharged, aqueous. But if you electrolyze zinc sulfate, aqueous, hydrogen will be discharged and never the zinc. So the same thing, if you electrolyze the aqueous solution of all these metals above hydrogen, you will rather get hydrogen instead of getting the metals. So we can never get potassium, calcium, sodium, magnesium, aluminum from the electrolysis of their aqueous solution, not electrolysis of their molten compound. Why? Because of the preferential discharge of hydrogen gas. That is it for position. Then concentration of ions. Concentration of ion is only applicable if the two ions are close in the series. For instance, if you concentrate calcium more than sodium, calcium will be discharged. If I concentrate silver more than gold, silver will be discharged. But if I concentrate sodium maybe 10 times hydrogen, sodium can never be discharged because their distance is far. So concentration will only have effect for ions that are relatively close. So like sodium and hydrogen, concentration will not have any effect because they are far. But if you see zinc and iron, mix them, iron will be discharged at all circumstances. But if we increase zinc, concentration of zinc like 4 times that of iron, you will get zinc instead of iron. The same thing is applicable when you come here. You see bromide ion. If you increase concentration of bromide ion more than hydroxyl, bromide will be discharged. The same thing is to chlorine because they are still a bit close. But looking at this one, fluoride ion, no matter how you increase the concentration of fluoride ions will never be discharged in the presence of OH. OH must be discharged completely before anything will happen to fluoride ion. But if you see iodide ion, if you use a concentrated solution of, the implication is this, common question in exam, they usually use brine. And what is brine class? Brine means concentrated sodium chloride. Nobody will tell you that. Brine is concentrated sodium chloride. So if they say electrolysis of brine, remember that when we say concentrated sodium chloride, water is small and salt is more. And the salt is the source of chlorine. That means chloride ion is now higher than hydroxyl ion. So at the anode, concentrated sodium chloride, remember, is aqueous. NaCl will give you Na plus and Cl minus, where water will have hydrogen plus and OH minus. This one is sodium and hydrogen. Concentration will have no effect on the two. Reason is because sodium and hydrogen are very far from each other. Look at sodium. You have to count 1, 2, 3, 4, 5, 6 before getting it. They are very far. So hydrogen will be discharged. Factor 1 will take over. Concentration don't have effect. What will determine what will be discharged now is just that position. Hydrogen will be discharged at the cathode and not sodium. But if you come to the anode, look at, they are not separated. When ions are not separated by more than 3 or more than 2, yes, take it more than 2. When the competing ions are not separated by more than 2, what is in between chloride ion and OH is 2. Concentration will have effect. So when they say brine, it means concentrated sodium chloride, which means chloride ions are more concentrated than hydroxy. So at the anode, what will happen is no more this equation that will happen. Rather, during the electrolysis of brine, what will happen at the anode is that chloride ion will be discharged. This is, since they say brine, what will be discharged is chloride ion, and this is the formula for chloride ion. I told you earlier, if you see minus, you just say minus E to give you Cl. but chlorine is diatomic gas, so we need to make it 2, and this should be 2 and this should be 2. Then conventionally, watch this, 2Cl minus. What happens? Let this minus 2E cross the sign. It becomes Cl2 plus 2E. Yakubu, you're welcome. You're welcome. Thank you for joining our live stream, my live stream. So this is the equation at the anode during the electrolysis of brine. What did I say brine is? Brine is concentrated sodium chloride. But during the electrolysis of dilute sodium chloride, at the anode, what is discharged is oxygen gas. That is hydroxy ion. That is it. So let's take some questions from the past question we have. All right, I'll still come back there. This one said, I can't really read it well. This is hardness of water, which is a simple. Let's go to the part that is very, very clear. Okay. Think. This one says, name 3 gases that are called. The other one has a continuation. I need to get it before I will answer it. I'll find it, sure. Name the 3 gases. Name 3 gases that are collected by downward displacement of air. Downward displacement of air means upward delivery. It means that the gas is up, taking air down. Watch it. You must understand this term well for you to answer it well. You know that when you keep memorizing that this gas will be by downward, this gas. So name 2 gases that are collected by downward displacement of air, and I told you downward displacement of air is called upward delivery, while downward delivery is called upward displacement of air. This is what you don't want to do. Let me not hear you say that the 2 types of collecting gases over water are 1, downward displacement, and upward delivery. You are saying the same thing. Watch my explanation here. Let's divide this. Here is a gas, and the upper part is air. This one is called downward delivery. It's different from this one. Delivery is for gas, meaning the gas is delivered downward, while air is on top. The air is now told to move up, or I will displace you. Move from here and go up. That is upward displacement of air. This drawing you are seeing now on the screen is the same thing as what? Downward delivery, and the same time what? Upward displacement of air. Whenever you say displacement, mention air. Whenever you say delivery, say gas. Now if you look at this shows that the air is lighter than this gas. So this method is for gases that are heavier than air. They go down to carry air on top of them. But another scenario, which is the question is asking us for gases that are, watch this, here is the air goes down, so that it tells the gas, come on, go up, be delivered upward, don't come down here because I'm heavier than you. So what is here is now gas. So this one is called upward delivery of gas, which is the same thing as the air is told go down, which is the same thing as downward displacement of air. So this one, the gas is on top, which means it's lighter. So this particular one, A and B. A is for gases that are lighter than air. B is for gases that are heavier than air. So they ask us downward displacement. Downward displacement is method of collecting gases that are lighter than air, because downward displacement of air means air is down and the gas is floating on top of it. Examples: hydrogen gas, ammonia gas, methane, These gases that are lighter than air are collected by what? Downward displacement of air, which is the same thing as upward delivery of gas. Okay, so let's now tackle the question. Remember, you are on with Majestic Tutorials, the home of the best experts in across all the subjects. We'll be bringing you both art and science subjects. So having explained this, they say name triggers. I've done that. Remember, you're allowed to write symbols or spell well. Hydrogen gas, ammonia gas. How do I know they are? You can chat me. I'll give you a link of the video that teaches how to know gases that are heavier than air and gases that are lighter than air. And equally methane. So they are all collected by what? Downward displacement of air or the upward delivery. Give a reason for the answer stated in 3DI. I think I've answered that. Can you give us a reason? What's my reason? Because the gases are lighter than air. Because the gases are less dense than air, if you like, are less dense than air. Or you say, or are lighter than air. So the mechanism is you carry what is lighter than you, but what is heavier than you will carry you. All right, I think this is it for this page. It's always good I go across the questions available. I think the person that asked about the preferential discharge, I've settled you. For the moment of time, remember you're watching Majestic Tutorials, where top educators deliver simplified lessons across major art and science subjects. A true hub of expert teachers and impactful learning. As you enjoy this class, don't forget to subscribe and share. If you have not subscribed, just share if you have subscribed. And then remember that I also supply laboratory apparatus and reagents. So these are the things, the services I give. Remember, this class is revision classes. Somebody asked me which year is that. This is actually GCE questions. So, but if you listen well to my explanation, you will definitely come out smiling. Those that are online, give this video thumbs up. The video is waiting for your approval. Give me thumbs up, share with others. It is purely revision question. It is no way connected with examination malpractice. We may not give you fish, but we'll teach you how to catch your own fish. I guess it's better. Instead of dashing you money, we'll teach you how to make your own money. Okay, we go down. See the questions. This question keep popping. Maybe you want us to answer it. Okay, I think this is the beginning of that question. They say 2,000 monomer units of an alkene. Thank you for liking. 2,000 monomer units of an alkene undergoes addition polymerization to form a polymer with relative molecular mass of 84,000. What is the empirical formula of the alkene? Okay. Remember, they say 2,000 monomers. Give us what? 84,000 as the mass of the polymer. So you have to get the molar mass of one of the monomer. Mono means one, ma means unit. So monomer is just one unit or the building unit that makes up the more complex unit or the giant molecule known as polymer. Just like you have your house, for you to build a house. You're welcome, Daniel. This is just a revision class in case. Thank you. To tell you what concept of monomer is, this is a molded block. What masons will do is to join them. And when they keep joining them, guess what? They are getting a wall. When they keep joining the wall, they are getting a partition, different partitions down to room. Are you seeing it now? So room can be seen here as polymers. The whole building is a polymer. Building is very giant, but the block, Songo Israel, thank you so much. Thank you for the applaud. So I pray it helps us tomorrow in the exam. Remember, I'll be there for your jam, for private tutoring. Please, if you need private tutoring across all the major subjects, contact the Majestic Tutorial plus 234 7065 166 217. With us, 350 is assured for your jump. Sure. With what you are seeing, I believe you have. I've done this teaching. This should be my 16 years ahead, exactly. Professionally teaching chemistry and biology. I will handle you in chemistry and biology, but I have also experts that will take you in physics, mathematics, English, literature, all the fields. Just contact the Majestic Tutorials. We got you covered. Okay? So, let us see. And probably we also, for now, our channel is already okay for membership. You can be a member of this channel to give us support. Now, these are each of these units is what we call monomer. Then this large thing you are seeing is now polymer. So polymerization is the joining or linking of smaller units to form larger units. You get it now? So now they told us we have two types of polymerization: addition polymerization and condensation polymerization. Addition polymerization and condensation polymerization. They are specific here. They said an addition polymer. Addition polymerization is a situation whereby no molecule is removed. Garbage in, garbage out. The exact thing you put in is the same thing you will get back. The exact, if you put 10 as your monomer, you will get 10 as your polymer. Meaning, if the molecular mass of the monomer is 2 grams and you happen to put 5 units, your polymer will be 10. Nothing is lost. But in condensation polymer, you will get a polymer that is less in weight than the monomers that makes it up. In this case, 2 grams times 5, your polymer might weigh 9.5. Something is lost. Small molecule, such as water, ammonia, HCl. Thank you for the like, is lost. So we call it condensation. But they are very clear here that is addition polymer. Although NECO, their question will not be as difficult as this, but just use this thing to learn, okay? These days they try to give you guys bonus. Since the molar mass of the polymer is 84, while 20 units, so we can find the molar mass of one monomer by saying 84,000 divided by what? 2,000. So we have 84. Cancel. So the 0 is just confusing us. There we have now 84 divided by 2, which automatically gives us 42 grams per mole. So the molar mass of one monomer is 42 grams per mole. How did I do that? By dividing 84 by 2,000. Maybe I still use calculator, provided they will not do nonsense advert, because I connected this thing to internet. I know they will do advertisement for me. So 80 what? 84,000 divided by 2,000 is 42. So I was correct. We go back. So we have gotten they say, what is the empirical formula of the alkene? We now solve. We have already known, they said alkene. Alkene. What's the empirical formula of the alkene? Why are we wasting time there? Victor Bassett. Okay. That's nice. Thank you for thanking me. Just subscribe and spread the good news. remember that we are available for tutoring for your first year in the university, second year. Our job is to make you pass well. Then for science lovers, visit Her Majesty Easy World Science channel. That's where you see many experiments. All these things I've been explaining, I do them also. Let's focus and solve this question. They ask us to calculate the empirical formula of the alkene. We already know that alkene has the general molecular formula of CnH2n. Simple. We equate it to what? We will equate it to 46. When we do this, we take it to the lowest formula because it's supposed to get the simplest formula. Okay? So by so doing, CnH2n, you have to factorize CH2 bracket n is equal to 4. Is it 46 or 42? It's 42, please don't mind me. It's 42. So carbon is 12. They will give it to us at the end of the question. Oxygen, carbon is 12, hydrogen is 1. So CH2 means 12 plus 2. 1 times 2 is 2. 12 plus 2, because 12 times 1 is 12. So we have 14n is equal to 42. Divide by 14. Divide by 14. So 42 divided by 14, please. What do you think? Divide by 14 is 3. So we have 3. Our n is 3. The molecular formula is C3H6. But the empirical, since it's alkene, is automatically CH2. So all alkenes have the empirical formula of CH2. You can even answer this without having to solve. It is the second one that I just solved, that one that we saw in the other page. You can simply say, since it's alkene, it is CH2. That's the empirical formula of all the alkenes. Okay? Settled here. Can go to the next. They now say, this one is different. We will still come back to this one. Oh, this was the biology class. Yeah, this is the continuation. They say determine the molecular formula of the alkene. I've done that already. That's just what I solved there. So I'll skip that one. In case if you don't understand what I mean, you still say CnH2n is equal to 42. That means 14 bracket n is equal to 42. So that n here is 42 divided by 14, giving you 3. The empirical formula is C3H6. Or you can say, alternatively, you can just simply go straight forward and say CH2, which is the empirical formula, equal to 42. You still land at 3. Then the next one says, name the alkene. So what's the alkene? C3H what? 6 is called what? Propene. Don't say propan 1N, in the sense that we don't have any other propene, meaning even if I have something like this, it is still propan 1N. If I decide to bring the double bond this way, it is still propan 1N. Therefore, just say propane. In your house, if you are the only David, is there any need of saying David 1 or David 2? No. So we can't have propane 2. So we just say propane. But if you say prop 1N, nobody will penalize you. Now, under what condition do real gases deviate from ideal gas? This is now ideal gas behavior. Under what condition do real gases deviate from ideal gas? Please let us, if you are a Nigerian, the election that happened 2000 and I don't know, but the year Peter Obi and Tinubu contested, you see Southerners, especially the Igbo people, were celebrating, and most other parts of Nigerians were happy as they were counting the votes by Peter Obi. They were singing LP. LP. So can somebody say low pressure? I just share this story so that you don't forget. At low pressure and high temperature, this is when real gases behave like ideal gas, but they are asking us the opposite. They say deviate from ideal gas. So I have said, what are the conditions? Low pressure and high temperature. That is when real gases show the least deviation from ideal gases. So I decided to say equal to here. Remember, ideal gas do not exist. An ideal gas is a hypothetical gas. It is assumed. It's a perfect gas. It doesn't exist, at least because of van der Waals forces. Because of yes, of course, there are many other weak forces that is responsible for the non-ideal behavior of real gases. So remember, real gases are not expected to liquefy. You can never liquefy them. They are constantly in random motion, moving. The space occupied by real gases is considerably okay, but the space occupied by ideal gas is negligible. So ideal gas don't occupy space. Ideal gas never liquefy. They keep moving. So thank you for liking. Please endeavor to share. So if you say LOP 21, LOP 27, LOP, that's low pressure. I got you there. So at low pressure and at high temperature, real gases do not deviate from ideal gas much. They show less than 1% deviation. So the opposite will be the answer here now. They told us, under what condition do real gases deviate from ideal behavior? Perfect behavior. What are those perfect behavior? They never liquefy. They're supposed not to occupy space, okay? And they should be in constant random motion. They should be moving forever, which you and I know it is not true. Gases liquefy. At least we have LPG, which is called liquefied petroleum gas. The one we use for cooking is liquefied. When you shake your gas cylinder, you can notice liquid, but that's a gas. What will make you understand that it's a gas? If you open it, it will escape as a gas, okay? Now, at what condition? This is the opposite. At high pressure, this is high pressure. That's when you liquefy gas. You liquefy gas by increasing the pressure at high pressure and at low temperature. That is when real gases show the maximum deviation from ideal gas. Okay, I taught you two ways so that no matter how the question comes. Now, which postulates of the kinetic theory of gases are not true under the conditions stated? Exactly this thing I say. The postulate is that the gas molecules are in constant random motion, colliding with one another. It is no more in constant random motion here. They have been compressed. Another statement is that the volume occupied by the the force of attraction between the gas molecule themselves is negligible. It is no more negligible here because they have been compressed. They have been forced to come together and they now liquefy. So the statement you write here, the one that says that the cohesion force between the gas molecule is negligible, is no more true under this condition. Cohesion force between the gas are negligible. It is no more true. It's no more negligible because